directions, the concept and tricks you're supposed to learn. So this particular slide will tell you, we can say next 4 or 5 slides will tell you, we can say the concept and the tricks as far as the directions, and you should have, we can say, direction sense. So that will be easy for you to solve as far as the GATE examination is concerned in the aptitude side. Typically in such type of questions, the question stem contains a number of instructions regarding the movement of a person. We are asked to find out the final location of the person or a distance traveled by him or distance between initial and final position. Under the concept and tricks, the introduction part, very important we can say, because we are going to learn the various different directions, which is very, very important to solve the direction sense problems as far as the GATE aptitude is concerned. Before doing this topic, the following points should be kept in mind. The first one, while attempting direction test, one must first understand the directions. The following figure shows the 4 main directions. That means north, south, west, and east. We are so familiar about this one. In addition to that, also 4 cardinal directions, northeast, between we can say north and east. The next one is northwest, between north and west. Then southeast between south and east. Then southwest between south and west are shown to help students know the directions. So before taking to problems of direction sense, this particular, the 4 important directions, in addition to that, the other 4 cardinal directions. So totally we can say the 10 directions you are supposed to learn very correctly. Otherwise, it will be slightly difficult for you to answer these questions. Point number 2 under the concept of tricks. One should start solving the question taking the initial position as origin. So very important one, the point number 2. One should start solving the question taking the initial position as origin. Point number 3 under the concept of tricks. For solving direction reasoning questions, it is critical that we have a different sense, direction sense after movement. Keep in mind the change in direction when a person takes right or left. Very important one. So this is a very important point actually. So for example, that is a direction before taking the time. If the person is facing north means, if it is moves right means east, if it is moves means left. This particular table also, it is very important. And if the person is taking the time, we can say direction before taking the time. If he is facing south means, if takes right means west, if he takes left means east. Similarly, direction before taking the time, if he is facing east means the person moves right means south and left means north. The last one, direction before taking the time, west means if it is moves right means north, if it is moves left means it is south. So very, very important this one. So this particular area you are supposed to learn, we can say correctly, so that you can solve, we can do the problems very easy. Under the concept and tricks, the 4th point is one should keep in mind that in finding the distance between initial and final position, the shortest distances is to be taken and use of by Pythagoras theorem is there, so that we can learn. So I'll tell you, you can say what do you mean by Pythagoras theorem. So once again, I'll read out this one. Under the concepts and tricks, the point number 4, one should keep in mind in finding the distance between initial and final position, the shortest distances is to be taken and the use of by Pythagoras theorem is there. So we'll study in detail what do you mean by Pythagoras theorem. It is quite easy because in the mathematics we have already learned, so that I'll tell you, we can say what do you mean by this one. So concept of Pythagoras theorem. The next important point that needs to be kept in mind is that directions problems generally quiz you about the minimum distance, distance by air, crow flight distance, etc. For the purpose of solving these questions, we assume all these distances to be along straight lines and between specified points. We'll use the concept of Pythagoras theorem to solve the questions on directions. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if we take this particular diagram, so root of c square is equal to the sum of squares of the other two sides, for example, a square plus b square. So if you draw the diagram, if it is comes like this, we can say the shortest distance. That will be easy so that we can make us the Pythagoras theorem to solve the direction sense problem. Let us understand the above discussed concept with the help of some solved examples. So once again, the Pythagoras theorem is very important because we have learned, we can say, in the mathematics in the lower classes, but still it is my duty to make you remind and to understand what do you mean by Pythagoras theorem. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. For example, this hypotenuse is designated by C. The other two sides are, we can say, A and B, that is in the diagram. So root of C square is equal to square root of the C square is equal to the square root of the sum of the other two sides, for example, A square plus B square, so that we can very easily solve, we can write the problems. So basic concepts, direction. In this article, we are going to discuss how to solve direction sense test questions in reasoning. Questions based on the concept are frequently asked in various aptitude tests and competitive exams. Directions questions asked in the exam are based on two basic principles. We must know, we can say, what is the basic principle. The first point you need to remember is that each main direction change undergoes a 90-degree change in direction. Example, from north to west, east, it will be 90-degree change. But the change between north and northeast is only 45. So main direction we can write changes 90-degree change. But between, we can say the main and the cardinal we can write. For example, north to northeast is 45, or south to southeast is 45, or in general we can say north to east is 90, or east to south is 90. So this is also very important, we can say, the direction sense as far as the problem is concerned. Basic concepts. So this one is also very important one. Left right movement, because as I told you, in the form of a table, but if you say in the form of a directions, so it will be easy to learn. So first one is left right movement. The person facing north on taking left will face towards west, and on taking the right turn towards east. So if the person is facing north means, if it is moves left means he is moving west. If it is moves right means he is turning towards east. So this particular diagram that is given in the slide also, it is very, very important, we can say, as far as to solve the aptitude test as far as GATE examination concerned. Now the person is facing west means on taking left will face towards south, and on taking a right turn towards north. Second point. The third point, a person facing east on taking left will face towards north, and on taking right turn towards south. Now a person is facing south means on taking left will face towards east, and on taking the right turn towards west. So these 4 points are very, very important in order to solve, we can say, direction sense problems. Whenever a person moves to his left side, he will move anti-clockwise direction. Very important one. He will move towards clockwise direction. Whenever a person moves to the left side, he will move towards anti-clockwise direction. Whenever a person moves to his right side, he will move towards clockwise direction. So left means anti-clockwise and right means clockwise. So these are all the points we should keep in mind, we can say, before taking into the problem. And if we solve, we can write as many problems as possible so that all the points will come to mind, so that it will be easy to crack down the exams. Very important one note. When a question says move towards left or right side, we assume that the moment is at an angle of 90 degrees. So this is also very important. When a question says move towards left or right side, we assume that the moment is an angle of 90 degrees. That means north to east, or east to south, or south to west, or west to north, of course. So main directions. Otherwise, it will be indicated specifically in the problem. We can say north to northeast, we'll say. So we'll assume that we can say it is 45 degrees rotation, of course, moment. Otherwise, we can say when a question says move towards left or right side means we assume that the movement is at right angle 90 degrees. Now we'll go for, we can say, some solved examples. A man goes 3 kilometers east from point A and then takes a right turn from point B to move 4 kilometers to point C. What is the minimum distance between point A and point C? I'll read out once again. A man goes 3 kilometers east from point A. Then he takes a right turn from point B to move 4 kilometers to point C. What is the minimum distance between point A and point C? The solution is, in order to find the minimum distance between these points, we use a little bit of geometry. We know that the minimum distance between these points will lie along the hypotenuse of the right-angled triangle formed by these points. Now, applying Pythagoras theorem, the distance between the starting point A and the final point C is 5 kilometers. That means the square root of the sum of the squares of 3 and 4. So how to find out it is a right angle means we are supposed to draw, we can say, the diagram. Unless you draw the diagram, it is slightly difficult to solve this problem, we can write. So understanding the basic concepts and tricks and the points and the basic principles, you have to read out we can say, the problem, we can say, very clearly twice or thrice, and draw, we can say, the diagram based on the theoretical aspects with all movements, we can say, whether it is north, south, 90 degree or 45 degree. And from that, we have to find out the shortest distance. And very important, we can say we have to start from the initial position. So if the diagram follows, we can say a Pythagoras theorem, a right angled triangle, then we'll apply, we can say the Pythagoras theorem to find out this problem. So as far as the problem one, the explanations are. An important point to learn from this question could be the fact that you might be asked to specify the direction of the specific point. For example, the question might state in which direction is he with the respect to the starting point. The answer would be southeast. Now, in case the question was in which direction is the starting point with respect to C, the answer would be northeast. Another question could be in which direction is he walking towards point C? The answer would be south. So while calculating the distance from a starting point to the destination point, when the points form a right angled triangle, the prior knowledge of Pythagoras triplets, that is 3, 4, 5, 5, 12, 13, 8, 15, 17, etc., is generally very helpful in calculating the distance involved, as it saves time spent on calculations. Let us solve an example that uses this knowledge. Example 2. A child is looking for his father. He went 90 meters in the east before turning to his right. He went 20 meters before turning to his right again to look for his father at his uncle's place 30 meters from this point. His father was not there. From here, he went 100 meters to the north before meeting his father in a street. What is the smallest distance between the starting point and his father's position? The options are given as 80 meters, second one is 100 meters, and third one is 140 meters, and the fourth one is 260 meters. So based on the theoretical aspect, if you draw the diagram, it is the point between, we can say, A and B. So for example, that is what is the smallest distance between the starting point and his father's position. The starting point is A and the father's position is E. So starting point, we can write A and the father's position is E. So the shortest distances we can write A and E. So that is the solution. If you see, the movement of a child from A to E is shown in the figure. So clearly, the child meets his father at E. Now we have to find out, we can say, distance between A and E. Now AF is equal to 90 minus 30 meter is equal to 60 meters. EF is equal to DE minus DF is equal to DE minus BC. So that we can find out 100 minus 20 meters is equal to 80 meters. So we are going to find out, we can say, the other two sides. Because we are not supposed to calculate, we can say A to B. We have to calculate, we can say AF and EF, of course. So AF is equal to AB minus FB, so 60 meters. And EF is equal to DE minus DF is equal to 80 meters. Now the distance we want to find out, you can say A and E. So now the distance square root of 60 square plus 80 square, which will be 100 meters. So it is very clearly that we can say we have used the Pythagoras theorem to solve this particular problem. We can clearly see from the above example that knowledge of basic concepts can go a long way in reducing time you take to solve problems. Along with the improving your accuracy, make sure you place sufficient emphasis on the topics such as direction-based questions, and your performance is surely meant to improve. Now we are going some different types of examples. Type 1. Siva, starting from his house, goes 5 kilometers in the east. Then he turns to his left and goes 4 kilometers. Finally, he turns to his left and goes 5 kilometers. Now, how far is he from his house and is what direction? So as far the solution is concerned, so 5 kilometers he is going to the east. Then 4 kilometers, then he turns to his left and 4 kilometers. Finally, he turns to his left and goes 5 kilometers. Now, how far is he from the house and what direction? So that is, if you see this one, the solution from the third position, it is clear he is 4 kilometers from his house in his north direction. So this is a quite simple example so that you can very easily find out, we can say, the answer. Now type 2, Suresh, starting from his house, goes 4 kilometers in the east. Then he turns to his right and goes 3 kilometers. What minimum distance will he covered by him to come back to his house? So the directions we have drawn here, that is the minimum distance. For example, that is we have made use of the Pythagoras theorem. So the distance between, we can say the shortest distance they are asking. So what minimum distance will he be covered by him to come back to his house? So the other sides of the distances are 4 kilometers and 3 kilometers. So minimum distance is equal to root of the square root of the sum of the, we can say, the other sides. So 4 square plus 3 square. So 16 plus 9 is equal to square root of 25 is equal to 5. So the minimum distance will be covered by to come back his house is 5 kilometers. Type 3. One morning after sunrise, Juhi, while going to school, met Lally at Boring Road crossing. Lally's shadow was exactly to the right of Juhi. If they were face to face, which direction was Juhi facing? So this is also quite interesting, and we'll let us take down, we can say, the solution so that it will be easy for you to understand. In the morning, sun rises in the east. So in morning, the shadow falls towards the west, of course. It is very clear. Now Lali's shadow falls to the right of Juhi. Hence Juhi is facing south. So this is what we can say, the answer. In the morning, everybody knows we can write. In the morning, sun rises in the east. So in the morning, the shadow falls towards the west. Now Lali's shadow falls to the right of Jogi. Hence Jogi is facing south. Type 4. I'll read out this one. So please listen carefully so that you can understand. Hema, starting from her house, walked 5 kilometers to reach the crossing of a palace. In which direction she was going? A road opposite to the direction goes to an hospital. The road to the right goes to a station. If the road which goes to station is just opposite to the road which IT Park, then in which direction to Hema is a road which goes to IT Park? So the diagram is clearly given. So if we take the solution, from the crossing, it is clear that the road which goes to IT Park is left to Hema. So the answer for this particular question, from the crossing, it is clear that the road which goes to IT Park is left to Hema. Now that is, we have learned, we can say, the basic concepts, tricks, basic principles, Pythagoras theorem, etc., etc. Everything is we have learned, we can say. Keeping in mind, I can say that is we have taken, we can say, some solved problems, different types of problems, so that now that is we are going for, we can say, solve numerical problems as far as we can say the graduate aptitude test in engineering is concerned. So the aptitude side, so these are the questions will be appearing, so that we will take some quite interesting problem for the next 30 minutes. Example 1. One morning after sunrise, Amrit was standing facing a pole. The shadow of the pole was forming on the left side. Which direction was Amrit facing? The options given are east, B is west, and C is north, D is south, and E is none of above. So if you see the solution, so once again I'll read out the problem. One morning after sunrise, Amrit was standing facing a pole. The shadow of the pole was forming on the left side. Which direction was Amrit facing? So east, west, north, south, none of the above. Now the solution. Sun always rises in the east. So in morning, the shadow falls towards the west. Now pole's shadow falls to the left of Amrit. So he is standing facing the north. So the option is C. Problem 2. Sandeep walks 60 meters to the east. Then he turns left and walks 50 meters. Then turns right and went 70 meters. And then turns right again and went 50 meters. How far was Sandeep from the starting point? So once again, Sandeep walks 60 meters to the east. Then he turns left and walks 50 meters. Then turns right and went 70 meters. And then turns right again, went 50 meters. How far was Sandeep from his starting point? The options are A, 90 meters, and B, 70 meters, C, 50 meters, and D, 130 meters, and E, 100 meters. If we see the solution, so that is, as far as the diagram is concerned, the distance traveled by Sandeep from the starting point, AB, is equal to 60 plus 70 is equal to 130 meters. So obviously the answer is D, 130 meters. Problem 3. Ahmedabad is to the southwest of Bangalore. Chennai is to the east of Ahmedabad and southeast of Bangalore. And Delhi is to the north of Chennai, in line with, we can say, Ahmedabad, Bangalore. In which direction of Bangalore and Delhi located? So since it gives, we can say, southeast, etc., etc., so that it will be easy. So that is, we have studied, we can say north to east means 90 degree, north to northeast means main direction to cardinal means only 45 degree, and main to main means 90 degree rotation. So that we have to keep in mind. So the options are, so once again I'll read out the problem. Ahmedabad is to the west of, southwest of Bangalore. Chennai is to the east of Ahmedabad and southeast of Bangalore. And Delhi is to the north of Chennai, in line with Ahmedabad, Bangalore. In which direction of Bangalore is Delhi located? So the options are A, south, B, southwest, C, north, D, northeast, and E is east. So as far as the solution is concerned, Delhi is located in the northeast of Bangalore. So the option is D, northeast. Problem 4. A person starts from a point A, walks 5 meters towards south and reaches point B. He then turns left and walks 8 meters and reaches point C. He then takes a right turn and walks 6 meters. He takes a final right turn and walks 8 meters to reach point D. So what is the distance between point C and D? So once again, a person starts from a point A, walks 5 meters towards south and reaches point B. He then turns left and walks 8 meters to reaches point C. He then takes a right turn and walks 6 meters. He takes a final right turn and walks 8 meters to reach point D. What is the distance between point C and D? So if we draw a suitable diagram, we can find out, we can say the shortest distance or the distance between C and D is almost, we can say, applies the Pythagoras theorem. And you are supposed to know, we can say, the distance of the sides. The options are A, 13 meters, B, 12 meters, and C, 10 meters, and D, 15 meters. So that we'll see what happens to the problem. Distance between C and D. So distance they are asking, we can say the hypotenuse. So hypotenuse is equal to the sum of the squares of the square roots of the other sides. For example, 8 square plus 6 square is equal to square root of the sum of 64 plus 36 is equal to square root of 100 is equal to 10 meters. So the answer is C. Now we are taking, we can say, problem 5. A car started from point P and moves towards east. After moving a distance 30 meters, it took a right turn. Again, after moving 15 meters, it took a left turn. And again, after moving 10 meters, it took a right turn. Which direction is the car facing now? So I'll read it once again. A car started from a point P and moves towards east. After moving a distance of 30 meters, it took a right turn. Again, after moving 15 meters, it took a left turn. And again, after moving 10 meters, it took a right turn. Which direction is the car facing now? Now, as far as the diagram is concerned, the options are given. A is north, B is south, and C is west, and D is northwest, and E is known as southwest. Let us see, we can say the solution. Since the car is facing the south direction, the answer is B, that is south, of course, as far as this problem is concerned. Now we are going for, we can say, problem 6. A directional post is erected on a crossing. In an accident, it was turned in such a way that the arrow which was first showing east is now showing north. A passerby went in a wrong direction thinking it is east. In which direction he is actually traveling now? Quite interesting. I'll read out once again. A directional post is erected on a crossing. In an accident, it was turned in such a way that the arrow which was first showing east is now showing north. A passerby went in a wrong direction thinking it is east. In which direction is he actually traveling now? Now, if you see the solution, when the arrow turns, north becomes west, east becomes north, south becomes east, and west becomes south. So he travels in the south direction. So the option is D, south. Now coming to, we can say, problem number 7. A person walks 22 meters towards east from point A and turns his left and walks 6 meters. Again he turns his right and walked 7 meters. And he reached the point P after walking 6 meters towards his right. Finally, he turns right and stop at a point B after walking 19 meters towards the west from point P. What is the distance to reach the starting point from point B? So that we have given, we can say clearly the diagram. So once again, read out the problem. Please listen carefully. The problem is, we can say, sometimes seems to be quite lengthy or something. But if you apply the basic principles, etc., it is quite easy. But you are supposed to draw, we can say, the actual diagram, we can say, based on the direction sense. You should have a proper direction sense to draw the problem, we can say. A person walks 22 meters towards the east and point A and turns his left and walks 6 meters. Again, he turns right and walked 7 meters. And he reached the point P after walking 6 meters towards his right. Finally, he turns right and stop at a point B after walking 19 meters towards west from point P. What is the distance to reach the starting point from point B? The options are 3 meters, B 10 meters, C 4 meters, and D 5 meters, and E none of the above. So if you see the solution, 22 plus 7 minus 19 is equal to 10. So why is this 19? Because we have to subtract, we can say, the distance between, that is they are asking, we can say, B to P actually. So we have to sum all the, then we have to subtract, we can say, 19, so that we'll get, we can say, the answer is, what is the distance to reach the starting point from point B is known as 10 meters. So the answer is B. Now coming to the next problem. A man started walking from point A and walked towards north and stops at point B. Now he takes a right turn followed by left turn and stops at point C. He finally takes a left turn and stops at point D. Towards which direction the man has to from D to B if he walks 10 meters before turning each turn? So that is, please read this carefully and listen carefully. The options are A south, B north, C east, D west, and E southeast. As far as the diagram is concerned, we'll see the solution. The option A, that means south. That means if he walks 10 meters, towards which direction the man has to walk? From D to B, if he walks 10 meters before turning each turn. So the option is A. Next problem. A man walks 40 meters towards the north and he turns left and walked 40 meters. He then turns his left and walked 15 meters. He finally turns his right and walked 20 meters. So what is the distance he is from starting point and which direction? So the options are A 55 meters northeast, B 36 meters northeast, and C 65 meters southeast, and D 65 meters northeast, and E is can't be determined. So if we draw the diagram, we can write. It is obviously clear that we can write. It is applies, we can write the Pythagoras theorem. But we have to find out, we can say the other two sides, because the diagram is typically different. We have clearly understood, we can say the distance which is asked, we can say shortest distance applies Pythagoras theorem. With the other two distance, we have to be extremely careful in calculating the other two distances. So that is solution. So 40 plus 20 is equal to 60. And 40 minus 15 is equal to 25. So the other two distances are, we can say 60 and 25. We have to be extremely careful. So the square root of, we can say sum of 60 square plus 25 square is equal to 65, root of 65, north west, of course. So the answer is D, root of 65 meters northwest direction. Now problem 10. Pinky walks 12 meters towards southeast and stops at a point P, and then she walks 20 meters towards west, and again she walks 7 meters towards northwest direction and stops at a point Q. Finally, she walks 5 meters towards east and stops at a point S. She is facing which direction from starting point? So the diagram is very clearly, we can say, given. The options are A, southeast, B, northeast, and C is east, and D, southeast, and E, we can say southwest. So that is, if we see, you can say the options, and we can say the solution. The solution is E. That means she is facing which direction from the starting point? She is facing southeast direction as far as we can write from the starting point. So the option is E, southwest. Now problem 11. A car moves 20 kilometers westward and turns left and moves 10 kilometers. It then again turns left and moves 20 kilometers. It takes a 45-degree turn rightwards and moves straight and stops at a point S. In which direction is the car is from the starting point? So here also, so they have asked, we can say in which direction is the car is moving from starting point. So the options are northeast, B, northwest, C is east, and D is southwest, and E is, we can say, southwest. So the option is E. That means southwest. Now coming to, we can say, problem 12. A man goes towards east 5 kilometers. Then it takes a turn to southwest and goes 5 kilometers. He again takes a turn towards northwest and goes 5 kilometers with respect to the point from where he started. Where is he now? I'll read it once again. Problem number 12. A man goes towards east 5 kilometers. Then he takes a right turn to southwest and goes 5 kilometers. He again takes a turn towards northwest and goes 5 kilometers with respect to the point from where he started. Where is he now? The options are A, at the starting point, B, in the west, C, in the east, and D, in the northeast, and E is none of these. As far the diagram is concerned, we can see the solution. According to the question, the direction diagram is follows. It is clear from the diagram that both the starting and finishing point are same. So the man is at starting point A. See, the option is A, at the starting point. Now coming to, we can say, problem number 3. Nikhil walked 30 meters towards east, took a left turn and walked 20 meters. He again took a left turn and walked 30 meters. How far and in which direction is he from the starting point? So if you see the diagram, the options are A, 20 meters north, B, 80 meters north, C, 20 meters south, D, 80 meters south, and E, data inadequate. I'll read out the problem once again. Nikhil walked 30 meters towards east, took a left turn and walked 20 meters. He again took a left turn and walked 30 meters. How far and in which direction is he from the starting point? So if you see the solution, according to this question, the direction diagram as follows. The required distances from A to D they are asking. So AD is equal to BC is equal to 20 meters. So Nikhil is 20 meters north from his starting point. So the option is A, 20 meters north. Problem 14. Rakesh is standing at a point. He walks 20 meters towards the east and further 10 meters towards the south. Then he walks 35 meters towards the west and further 5 meters towards the north. Then he walks 15 meters towards the east. What is the straight distance in meters between his starting point and the point where he reached last? The options are A, 0, B, 5, C, 10, D, cannot be determined, and E, none of this. So this, as far as the diagram is concerned, let us see, we can write what is the solution. According to this question, the direction diagram is as follows. So from the diagram, AB is equal to 20 meters, BC is equal to HD is equal to 10 meters. So ED is equal to 35 meters. HE is equal to AF. So the required distance AF is equal to HF is equal to HD minus ED. So HD minus ED is equal to 10 minus 5 is equal to 5 meters. So it is very clearly that is what is the straight distance between starting point and the point where he is reached last is 5 meters. So the option is B, 5 meters. Now coming to, we can say, problem number 15. Ajay walks 24 kilometers towards east and turns right hand side and takes a drive of another 10 kilometers. Then he turning to his right, drives towards west another 10 kilometers. He then turns to his left and walks another 8 kilometers. After that, he turns to his right and travels 14 kilometers. How far is he from the initial point and which direction? The options are 20 kilometers east, 18 kilometers south, 16 kilometers west, and 10 kilometers south. And the other option is given last one, none of this. So as far the diagram is concerned, the solution is AB is equal to, they're asking distance between AB, 10 plus 8 is equal to 18 meters towards south. So as for the answer for the question, how far is he from the initial point and which direction means he is from 18 kilometers towards the south. 18 kilometers towards south. Problem 16. Raju walks 80 meters towards south, then turns to his right and starts walking straight till he completes another 80 meters. Then again turning to his left and walks 60 meters. He then turns his left and walks for 80 meters. How far is he from his initial position? The options are 100 meters, 60 meters, 20 meters, 120 meters, and 140 meters. As far the diagram is concerned, let us see, we can say what is the solution. So they are just asking the distance between AB. So it is obviously clear that we can say 80 plus 60 is equal to 140. So the answer is E, that is 140 meters. Now coming to, we can say problem number 17. Varun drove his car for 80 kilometers due north. Then he turned left and drove for 100 kilometers. Again, he turned left and drove at another 80 kilometers. Again, he turned left and drove his car, we can say 120 kilometers. How far do you think he actually drove his car from his initial position? The options are 20 kilometers, B 100 kilometers, and C 60 kilometers, and D none of the above, and D is we cannot say. So as far the diagram is concerned, let us see, we can say what is the solution for this problem we can write. So distance from initial position, that's equal to 120 minus 100 is equal to 20. The answer is A. Next one, problem 18. Ajay drives 3 kilometers north. Then he turns right and drives 4 kilometers. Now he turns right and drives 5 kilometers. Now turning left, he drives 2 kilometers. Again, he turns left and moves 2 kilometers. Finally, turning left, he again walks 2 kilometers. In which direction and how far is he from the starting point? The options are A 1.5 kilometers east, B 40 kilometers east, and C 1.5 kilometers west, and D 4.5 meters west, and E none of the above. Now, as far as the diagram is concerned, if you see the solution, Ajay is, we can say, 4 kilometers east. So the answer is, we can say, B 4 kilometers east. Problem number 19. A man walks 8 meters towards east to reach a point P. He turns to his right and walks 5 meters to reach point Q. Then he turns to his left and walks 9 meters to reach point R, and he turns to his right and walks 11 meters to reach point S. Finally, he turns to his right and walks 20 meters to reach point T. So what is the distance between starting point and Q? So once again, I'll read out this one. A man walks 8 meters towards east to reach point P. He turns to his right and walks 5 meters to reach point Q. Then he turns to his left and walks 9 meters to reach point R. And then he turns to his right and walks 11 meters to reach point S. Finally, he turns to his right and walks 20 meters to reach point T. What is the distance between state point and Q? Starting point and Q. The options are 13 meters, B 9 meters, C root of 89 meters, and D 3 square root of 27 meters, and E none of the above, of course. Now if you see the solution, it's almost we can write using, we can say, Pythagoras theorem, the point Q they're asking. So the other sides, of course, we can say 8 meters and 5 meters. So the distance between, we can say, the point at which we can say starting point and Q, is known as the hypotenuse. So you have to take, we can say, sum of the square roots of, we can say, 8 squared plus the other sides, 8 squared plus 5 squares. So that is equal to this square root of, we can say, 64 plus 25 is equal to root of 89 meters. The answer is C. So root of 89 meters is the correct answer. Now coming to, we can say, the last problem. Problem number 20. If a man walked 3 meters towards east from point T to reach point U, then what is the distance between point U and starting point? I'll read out this once again. If a man walked 3 meters towards east from point T to reach point U, then what is the distance between point U and starting point? The options are A 16 meters, B is 25 meters, and C is 22 meters, and D is 33 meters, and D is none of this. So let us see, we can write the solution. If we carefully watch the diagram, the distance between U and starting point is 11 plus 5 is equal to 16 meters. The option is A. So now we have completed, we can write 20 problems. Incorporating, we can say, almost all the basic tricks, the principles, the fundamentals, etc., etc., as far the direction sense is concerned. I hope, we can say, the students, those who are, we can say, listening to this particular class might have understood, we can say, what is direction sense, and you will be ready enough, we can say, sufficient enough to take up, we can say, the GATE examination as far as the aptitude test is concerned. So once again, thank you for your participation. I hope this lecture will be very useful in solving, we can say, especially on the direction sense problems as far as the aptitude test in GATE examination concerned. So once again, thank you for your participation, and God bless you all. Wish you all the best.